Another one is December 22nd. We are at 1998. Oh, this is getting exciting. We're almost there. Yeah, we're almost there. I've done this before. Oh man, can't see it. Two best non-overlapping events. You're given a zero-index 2D integer array events, where events I is start, end, value. The ith event starts and ends, and if you attend this, you will receive the value. You can choose at most two non-overlapping events to attend, such that the sum of the value is maximized. Return this maximum sum. The start time and end time is inclusive, that is, you cannot attend two events where one of them starts and the other ends at the same time. More specifically, if you attend an event and at t, the next has to be t plus 1. We are looking at 10 to the 5th, all right? So we have event, 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 so we'll take in two. I will just take the largest one. Oh, wait, hold a second. 1 to 3. Oh, this is 4 to 5. Then this is wrong. It should be 4. The end time. I think this represents the end time. Oh, this is confusing. 1, 2, 3. Yeah, this is confusing. I don't like how this one represents. But anyway. So anyway, we have, 0, 1, 2, 3, 4, 5. I'm looking at example number 2. Okay. So we have 1 to 3. And 4 to 5. And 5 to 5. Right? So the value is going to be 5 plus 2. Oh, my bad, 1 to 5. Jeez. 1 to 5. So yeah, you can only take 1, which is just this. Okay. So, well, usually we do this, we sort by something. Maybe we should sort by end instead of by start. If we sort by end, then yeah, we sort by something, right? We sort by something, and then we can say DP, right? Then let's say we have event 1, event 0, event 1, event 2, and then they are sorted by, let's say, sorted by end. So we have the earliest end. So we say DPI is, let's say, max value for attending, right? Attending events I to the end. Okay, so if we go from right to left, then DPD end is just going to be by itself, right? And then if we look for the previous one, I need to know how I can handle the remaining. Oh, then you should probably sort by the start, right? Yeah, I think let's sort by start. If we sort by start, and it's the same thing, okay? It's the same thing. We just say sort by start and end, right? So DPI is going to be from I to the end. What is the maximum? Okay, and then when we want to calculate DPI, right? So DPI is an event. Have a start, have an end. I don't care about start because if I take this, what's the next one I can take? So you need to find e plus 1, right? You need to find e plus 1. So what we need is to binary search this thing because I sorted by the start. So what is the earliest start that is larger or equal to this, or we can say earliest start that's larger than e, right? Earliest start larger than e. We find it, we get it, and that should do. So we need to sort, which I think I can just do directly. Now, binary search, I think it should be upper bound. Right? Can I reset this? So C++ upper bound custom, right? Custom comparator. Can I do? Yes, you can. Value and element. Search for the first element such that the comparator returns true. Okay. That I think will help. Let's do this. Two 054. Sort events by start, then DPI is the max value of attending two events. That's the thing. Can you either attend one event or attend two events, right? Max value of attending. Oh, max two events. Because you can only attend two events, which means for each one is you either attend it or you don't attend it, right? If you don't attend it, it's just gonna be the next one. If you attend it, you need to find. I don't even need to binary search. Right? Is the max value of attending at most two events in among events I to the end, right? I to the end. We need to keep track of the max, right? The suffix max, right? Suffix max value of all the events, and suffix max. I need to modify events. Yeah, suffix max, all the events. Then for event I can choose to not take it. Then the answer would be DPI plus 1, right? Or I can choose to take it. Then we need to binary search the suffix max, right? Binary search the suffix max and find the largest, and then find the first start time that is larger than the end time of event I. I mean, I should create a suffix max. I wonder, we don't need to. We don't need binary search. Then we need to find, right, the smallest, the earliest, right, the earliest event whose start time is larger than the end time in the suffix max array. Oh well, I don't need binary search for this. So, but I do need suffix max. So std vector at go n equal to events.size. There's gonna be vector std pair suffix max. Okay, size n. So element is start time suffix max value. Okay, then what we do is we'll put the last one in there. Right, so we say suffix. I don't actually need to keep a suffix max, right? Because this is the start, and I do this, and this is the max we have. Then we just, keep walking to the left. Right, keep walking to the left. Suffix int suffix max val shall equal to events n-1 2. That's the starting point. And int res will equal to suffix max val. Right? And for int I equal to n-2, I large equal to 0, I plus plus. Okay. So suffix max is, and then we have a j, int j equal to n-1, right? So j points to the element with suffix max. Then what we do is we can choose, right? Option 1 is, option 1, do not attend events I. So we say res shall equal to maximum res and, I do need a DP because I need the next one. But you don't need the next one. Next is 0. Right? Do not attend, so we take the next one. But I already have, so you actually don't need to even attempt this next. Because you just went from next. Right? You did that, and then we get res is the total maximum from this towards the end. Right, we know. So if we don't attend, then it's the same thing. I don't even need this next. So I'm gonna take it, right, I'm gonna take this value and, I didn't even sort. Okay. Then what I do is I look at here, I say if I attend it, right, the previous max is this, so if I attend it, so I take mine, and then I need to find move j to the left, right? So we say while while events j 0 start, if its start is larger than events I 1 and j need to be greater than I, right? We'll do suffix max equal to maximum suffix max events j 2 j minus minus, right? So j is pointing to j needs to point to the first that does not work, right? So j points into this, and we say if j is larger than I and it is good, then because this is the first one that is not, right? That is not so j is pointing to this, right? J pointing to this, and then I'm right here and I say I'll take j, I'll take it, right? I check if it's larger than, then I'll use it, right? I'll use it, I do my suffix max, so j move on to here, and eventually j will point into the one that does not work, right? J will point to the one that does not work, or initially j also does not work, right? So what I need to do is to check, right? Yeah, that's the thing, like because I need j to point into the first one, that because if it doesn't work, so I always need to use j plus 1, right? I always need to use j plus 1. So j plus 1 should be guaranteed to work, okay? J plus 1 need to guarantee to work. But if I have bunch of the same, like if towards the end, none of them work, like they all overlap, then I need an additional, yes, that's the thing. I need an additional event. So I need events dot push back. I need an additional one, which is events dot back, right? So we have 0, 1 is ending, right? So ending plus 1, so we guarantee that that they will work. Doesn't matter, it can be the same. But this one has 0 and doesn't have any value. So this is going to be n, that's just going to be 0, we know. Right, suffix max, rest is going to be this. So j equal to n points to the element, to the suffix max. So it's going to be from this, right? And be from this, because that's the first one that does not, yeah, so n is here, and then j0 is larger than, yes, so I do the suffix max, j minus minus, now j equal to I, so when I come out, so j plus 1 is, you can use j plus 1, so I say I'll take myself and I'll take that. Oh, go to sleep. No. Once was lost. It all began with the four sweet magic rings. Three given to the ones 7 to the dwarf lords. 3 minors. 9 given to man. Alright, let's get back to this. So we add a new element to the end. So I can do this, and then it will move, and then I can say j plus 1 is the next one, right? And then I can use it. Right? I can use it. I can say res shall equal to maximum res, and I'll take the current, right? And then it shall be two things, right? You can either take myself but don't do anything, or you don't take myself, you take, or you take myself. So like three options, right? Three options. So we can say option 1, do not attend events I. This has already been captured in res, right? So we don't have to do it. And then option 2, just attend events I. Then we need to find, then we need to take, then we can take events j plus 1. The max, then we can also take the max value when attending any events in this towards the end, right? And then the max value is captured by suffix max val. So basically when the events I0 I2, right, plus suffix max val. And then that's it. Now we move on to the next one, and then we see if j can do it. If j cannot do it, still gonna be, if j cannot do it, so still it's the suffix max, right? Until j can do it, then we move on, and suffix max is updated. And then at the end, we'll return res. Okay, so we're trying to do the most optimal DP in this case. Not sure if it's gonna work. Oh. My bad. Minus. Yeah, looks to be right. Nope, it's not right. It's like, it's the theme of these days. It never work the first try. So we have 10, 83, 53. Oh, we probably have to take care of this. Oh yes, we have to take care. Oh, okay. Yeah. So we do have to. I thought we don't have to. How can we do it so we don't have to? Maybe if we sort by end, right? Now if we sort by start, then we have something that ends that you cannot do. If we sort by end, this must be the last ending, but the start can be somewhere, right? So we have the start and end, and then the next one we have an end, but you cannot. I think either way it doesn't work. We have to binary search, right? I think we have to binary search. suffix sum just simply doesn't work because you don't know which one you need. Yeah, you don't know which one you need. So we need to do suffix sum, the suffix max, but we also need the indices because we start with the start time, right? So it's like start from here to the end, what's the max? Start from here to the end, what's the max? Start from here to the end, what's the max? And then, yeah, unfortunately. For that, I can choose not to take it. I can choose to take it, then we need to find the earliest event. Yeah, so when login. I thought we don't have to. But yeah, in that case, I probably don't need this. I will also edit directly, which I really shouldn't, but I am going to do it. I'm going to edit directly in this. Okay. I will modify events in place. So we don't need this. This I can probably say events stop back to, right? Don't need this. So we start from here. And let's just restart the whole thing. All right, so I have the end, so I just need to say binary search. So auto it, right, equal to upper bound events, right, events dot begin, events dot end, upper bound. How do I do upper bound? Begin and the value is going to be events I1 is the end, so it has to be larger than that. And then the I'll say right, int end time, and then const vector, right? There's gonna be a vector event return end time shall be smaller than event start, right? Okay, so if it, then if I don't take this, I mean just the next one, so I already done it. So if I take it, it's gonna even find that. So we say res shall equal to maximum res or events I2 plus it equal to events.end. If it is, that's going to be 0. If it is not, then it should be it dot back it is going to be a vector, right? So dot back no yeah, and then events I2 shall equal to maximum events I2 events I plus 1, 2. This is a suffix max. I mean, I think to be more explicit, we can do it too, right? This is the suffix max, right? And then we do this. All right, let's try this one. Huh. It must be this. Do I use iterator? Yeah, that's probably wrong. Iterator. But I thought this gave us yeah, let's just use int index distance events.begin it. So here we can just do events index and 2. Hopefully this one will be right. Huh? I am not sure where I got wrong. Where did I got wrong? Oh, I know where I got wrong. Yeah, it should be minus minus. I forgot. Oh, in that case, maybe I don't need this. I thought it was the issue of this, but I don't think so. So, I think this shall work. Okay, now we can submit. Yeah, I thought we'll be able to do it without setting up additional space, but it turns out you can't. $2024. Is that a priority queue? Oh, yeah, you can do that too. I mean, it's the same idea. So I will call it so yeah, so this is a prefix max. So we push the current in, right? We push the current in. So what we have in this priority queue is the top is the smallest event with the smallest end. So we keep going, and if the top is smaller than the current, then we keep, so those can all be taken, and then we find a maximum. Until we cannot, then we'll say the prefix. Yeah, it's the same idea. It's the same idea. All right, that will be it. We went through some detour, but eventually we got this one done. All right, I'll see you guys tomorrow. I think tomorrow is the last day, isn't it? Christmas Eve.